Okay, so in this video, we're going to look at combinations. And the key thing with combinations is that with these, order doesn't matter. And just like with permutations, it was easy to remember that a permutation was connected with an arrangement. For combinations, it is connected with your selections, okay? And so the best way to understand this is think about selecting a number of people for a team. And you want to find out all the different ways of selecting 5 people from 20 people. You want a team of 5 people and you've got 20 people to choose from. And you want all the different possible groups and selections that you could make. If you're just picking 5 on the team, but you've got 20 people to choose from. And so the order in which you pick those people on the team doesn't matter. What matters is just how many different teams there are. So we're going to jump straight into a question here, and then we'll write a little note on how we work these out. Okay, so let's take a look at this example. In how many ways can a team of 5 players be chosen from 9 players? So this is a very straightforward question that is a combination. Again, the order doesn't matter in how I pick the players. I just want how many different teams of 5 players can be chosen if I have 9 players to select from. And the notation I'm going to use with combinations is 9 choose 5. If I have 9 in total and I'm only choosing 5, this is the notation for these kind of combination questions. It can also be written as a 9 on top and a 5 underneath with large brackets. Here's where our calculator is going to come in though. Here we have above the division button is the NCR. Okay, so to access that, we're going to press the 9 first. I'm going to do this calculation on it and then shift. And then I'm going to press the NCR button so that C comes up just like that there. And then I'm going to press 5. So there's NC5, or written like that, equals 126. There are 126 different teams of 5 that I can select if I have 9 people to select from. Okay, so that's where that comes in. 126 is the answer. Okay, so here's a little note about that notation. So your NCR button on your calculator, also written, as I said, like that. This is the actual calculation that your calculator does. It will take whatever number you have here, that factorial, and then whatever number you have down here, it's that factorial, and then you do the subtraction between the two factorial. Now, you do need to be familiar with the actual calculation that your calculator does, because you can sometimes be given a kind of an equation using this notation where you have to solve for an unknown. We'll take a little look at that at the end of the video lesson. They're not terribly common, but it is something that could come up, and for that you just need to be familiar with the actual calculation that your calculator button does. So the NCR, that button on the calculator, and that calculation will work out for you the number of combinations of or objects chosen from a set of n different objects. Okay, so just like we saw with that example, let's go back to that example now and we'll look at part 2. So part 2 says, in how many ways can this be done if a certain player must be selected in each team? Now this is all about the choice, okay? Just like with permutations, it was all about how many options you had for the different positions. This is now all about what choice do you have out of how many. So if you know that a player must be on your team of 5, you now only need to choose 4 other players. And since that certain player must be on it, and is obviously one of the 9 players, he now is out of the selection for the remaining 4 on the team. So you only now have to choose 4 players, the other 4 on the team, because he is on the team, out of 8 in total to choose from. So this is 8C4. Again, can be written like this. And if I do that on the calculator, I'm going to press 8, Shift and the division button to get that NCR. The C should come up, 4 equals. And the answer is 70. Okay, let's take a look at this question. How many different selections of 5 letters can be made from the letters of the word chemistry? Okay, so that's the first part. So let's answer that straight away. Let's see, how many letters do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's 9 letters in chemistry, and I need to choose 5. There's no other restrictions than that. So it is 9C5, which is that. And of course, 9C5 is 126. Same calculation as the last one, actually, just by fluke. Now, part I. How many 5-letter selections can be made if the letter C is included in each selection? So here again, the C has to be in that selection. So now I'm only choosing 4 other letters from the remaining 8. So that's 8C4. This happens to be the very same calculations as the last one. Didn't realize, but anyway. We do have an extra question in this one. 70 is the answer there. All right, now part 2. How many 5-letter selections can be made if the letter C is always included and Y is always excluded? Okay, so now what's your choice? C has got to be in there, okay? Which means we have 4 other letters that we need to choose. But since the C is out of the picture, because we have it already, and now the Y is also out of the picture, because we can't have that, the other letters to choose from are the H, E, M, I, S, T, and R. So that's only 7 letters to choose from, but we still need 4 in the 5-letter selection. The C is in there, we need 4 other letters. So the last part is actually 7C4. Which works out to be 35. Okay, let's have a look at this example. In how many ways can a group of 5 be selected from 10 people? Okay, well, that's a straightforward question. We just have 10 to choose from, and we are choosing 5. So that's 10 choose 5. So on my calculator, it's your button there, of course, and 5, I'm getting 252. So no restrictions there on that first one. There are 252 ways of selecting a group of 5 if you have 10 people to choose from. Now, the second part, in how many ways can this group be selected if 2 particular people cannot both be selected for the group? Now, this one's harder, okay? They can't be both together on the group, okay? But you can have one or the other, or none on the group, right? There's a good few things to think about here. And the way we're going to look at this one is quite similar in the approach that we took with the tricky permutation question. If you remember the question that was about the letters being apart, the way we worked out when the letters were apart was we first worked out, well, how many different ways were there of the letters being together? And when you subtracted that from your total number of ways, you were then left with how many ways they had to be apart. This is a similar approach that we're going to do here, because this is harder to think about. There's a number of scenarios that satisfy 2 particular people not being both selected for the group. So what we're going to think of first is we're going to think of, if they are both on the group, how many ways is that? Okay, so if they both must be in the group, then we are choosing only 3 other people, with a group of 5 in total, 2 of them are on it. So there's only 3 people left to choose for the group out of only 8 people left to choose from. Okay, so if they're both in the group, it's 8C3 and 8C3 works out to be 56. So now, if there are 56 ways of them being together on the group, then if we now take our total number of ways and subtract all the ways that they would be together in the group, we are left with 196 ways then of them being apart, if you like, or not together on the same group. Okay, so that's the way we'll approach those tricky ones. Similar sort of thinking, as I said, as the tricky permutation question. Okay, next question. Find the number of ways in which a panel of 4 men and 3 women can be chosen from 7 men and 5 women. Okay, so here there's a little bit more to this type of question. All right. So let's have a look at the first bit. We want a panel of 4 men. And the 4 men can be chosen from 7 men. So just consider the men first. If I want 4 and I'm choosing from 7, it's going to be 7C4. Yeah? So that's the men sorted. Now I want the number of ways we can choose 3 women from 5 women. So that's going to be 5 choosing 3. And when you have this set up where I want the 4 men and the 3 women, if you remember from your junior cert probability, what calculation or what operation we used to connect with the word and in probability questions is always times, okay? So that's exactly what we're going to use here. If we want 4 men and 3 women, then we'll work out the number of ways of choosing 4 men from the 7 men that are available, and we'll work out the amount of ways of choosing 3 women from the 5 women, and we want both those things to happen, so we're times. So I'm going to work out 7C4, and I'm getting 35. I'm going to work out 5C3, and I'm getting 10. And of course, 35 times 10 is 350 ways altogether. Okay, let's have a look at this question. In how many ways can a committee of 6 be formed from 5 teachers and 8 students if there are to be more teachers than students on each committee? Right, so we haven't got a clear instruction here, and there are a couple of things that are going to satisfy there being more teachers than students on each committee. So let's have a think of this bit by bit. If we want a committee of 6 and we've got 5 teachers and 8 students to choose from, give me a scenario where there would be more teachers than students on the committee. What would that committee consist of, number-wise, in terms of teachers and students on that committee? Well, let's start with the most teachers we could have. I can only choose 5 from 5 teachers, which means I can't have 6 teachers. We've got to have more teachers than students on the committee. The most teachers we could have is 5 teachers, and then that would leave 1 student. So if we had 5 teachers and 1 student, that's a scenario that would satisfy more teachers than students on the committee. So if I'm choosing 5 teachers from 5 teachers, that's 5C5. And I want 1 student, and I can choose 1 student from 8 students, that's 8C1. So 5C5, if 5C5, if you're ever doing that where you have the same number choosing the same number, it is always going to be 1. There is only one option. You're taking the 5 teachers from the 5 teachers. That makes sense. And then I have 8C1. So now I'm choosing one student from the 8. There are 8 different students, obviously, to choose from there as well. So that makes sense as well. That's 1 times 8, which is 8. Now, let's have a look at another scenario. Another scenario would be if I had 4 teachers and this time 2 students. Now, if I want to choose 4 teachers from the 5 teachers, that's 5C4, and I want to choose 2 students from the 8 students, that's going to be 8C2. So 5C4 works out to be 5, and 8C2 works out to be 28, and 5 times 28 is 140. Okay, that's that scenario. Right, now let's think if there's another scenario. So what if I had 3 teachers and 3 students? Well, if I have 3 teachers and 3 students, that wouldn't satisfy there being more teachers than students on the committee. So I've only got 2 scenarios here that work, and I'm happy now that I have those 2. Now, here's the thing. When you've got 2 scenarios and you could have this or this. Now, do you remember again from your junior cert probability what operation and calculation you would have associated with the word or? The answer is addition. So since I could have this or this, I am now going to add 8 plus 140, which is 148 then ways in total. Okay, let's have a look at this question. A board of 6 members is to be chosen from 5 men and 3 women. In how many ways can this be done? If there have got to be 4 men on each board is the first question. Okay, so we've got a board of 6. I want 4 men, so I'm choosing 4 men from 5 men. And there's got to be 6 people on the board. So if I have 4, I need another 2 then. So if I have 4 men, 2 of them would have to be the women, and I can choose 2 women then from the 3 women available. So it's going to be 5 choose 4 times 3 choose 2, and that is 5C4 is 5, 3C2 is 3, so 5 times 3, because remember it would be 5 men and, 4 men and 2 women. Let's write that up here. So we understand the scenario we have. And of course, the and is bringing in my times, so 15 ways then of total of getting 4 men on the board. Okay, let's have a look at part 2. Now in part 2, what about when there is a majority of men on each board? Okay, so let's start with, given that there's a majority of men, let's start with the most men that we could have. And the most men that we could have, if we're choosing 5, is of course 5. So if we're choosing 5 men from 5 men, all right, this would be 5 men, and I would need 1 woman to make up the 6 on the board. So the and, bring times in, I want 1 woman, and I'm choosing from 3 in total. There's 3 available. So 5C5 times 3C1 is 1 times 3, which is 3. Now, that's one scenario. There is another scenario if we're going to have a majority of men on each board, and that would be if I had 4 men, and if I had 4 men, I would need 2 women. Okay, so one scenario, another scenario would be 4 men and 2 women. So if I'm choosing 4 men out of the 5 and 2 women out of the 3, that calculation is 5 times 3, which is 15. And then if we were to think about 3 men, that means we'd need 3 women. That would not satisfy there being a majority of men on each board. So my 2 options are 5 men and 1 woman, or, which means we're going to add 4 men and 2 women. So 3 add 15 then is 18 ways altogether. Okay, final example, and this is one that I said I'd come back to, where we are asked to solve for n here, and we may need to think about the actual calculation that the NCR button on the calculator does. Now, this is an easier one, I suppose. Now, I want to show you the thinking behind this easy one so that you'll be able to apply that approach to the trickier, harder ones that possibly could come up, okay? It is true for something like this, you could very easily just sub in some values and see what worked out, okay? However, the issue with, of course, a trial and error approach is that it could take a lot of time. You may not hit on the correct answer. And if it's a harder question than this, then you need to have a strategy. But it's always easier to understand a strategy with an easier type of question. So what I want to write down for myself first is what that calculation is, of course. NCR is when you have n factorial and you're dividing by r factorial times n minus r factorial, okay? So if I was just to put that calculation in here, I will get n factorial divide by 2 factorial, and then of course n take away 2 factorial is equal to 10. Technically, that is the calculation that that notation gives you. Now, what I want to explain is working with factorials, especially when you've got some algebra involved, and understanding how you can expand them out a little bit in order to be able to cancel, because we have a divide by n minus 2 factorial here. I am going to be able to get rid of that n minus 2 factorial because it is embedded within the n factorial, and that's the bit I want to explain. So before I jump into this bit here, I just want you to think of back to just a simple numerical example. Like, say you had 5 factorial, right? Let's remind ourselves what 5 factorial actually is. It is 5 times 4 times 3 times 2 times 1, isn't it? That's the calculation. Now, technically then, another way of writing this would be 5 times 4 times 3. And isn't it true that 2 times 1 is technically 2 factorial? Yeah. So, another way I could write it is 5 times 4 times, and isn't 3 times 2 times 1 technically 3 factorial? It is. That calculation is going to give you the same as that calculation, is going to give you the same as that calculation, is going to give you the same as that calculation there. And lastly, isn't 4 times 3 times 2 times 1, right? Put that 5 down there. Again, 4 times 3 times 2 times 1, isn't that the same as 4 factorial? And it is. So all of those calculations will give you the same thing. So I want you to expand out this n factorial a little bit. Given this kind of approach and this understanding, if I have n factorial, that's the same as n times, and then of course you'd multiply by 1 less than n, wouldn't you? Like we did here, 5 factorial, then we multiply by 4, which is 1 less than 5. So n take away 1, right? And then you'd multiply by 1 less than that, or 2 less than the original. Yeah, so 5 times 4 times 3. 3 is 2 less than 5, isn't it? So it's 1 less again. So n take away 2, take away 1, take away 1. And so rather than continue on down there, I'm going to stop here because I can just replace that with factorial. 5 times 4 times 3 factorial. Like if I want the rest of that, 3 times 2 times 1, it's just the same as 3 factorial. If I want the rest of that, n minus 2 times n minus 3 times n minus 4, and so on until you get to 1. It's just n minus 2 factorial. But the reason I want to stop there is because I have an n minus 2 factorial on the bottom there, okay? And now, because I've expanded out the top in that way, I'm going to be able to cancel all of that with all of that. And that leaves me then with n times n minus 1 on top and 2 factorial, which is just 2 times 1 on the bottom. And now this is a much easier equation to solve. I'm after getting rid of those factorials, which is what you need. You can't work with the factorials. You're going to have to expand them out and simplify it all down so that you can get rid of the factorial notation. And so what I'm left with here is n times n, which is n squared, and n times minus 1, which is minus n, all divided by 2 is equal to 10. And now what am I going to do? I'm going to get rid of that denominator straight away. Whenever you have a denominator, let's get rid of it. And because it's an equation, what I can do to get rid of that is I'm going to multiply both sides by 2. And that's going to give me n squared minus n is equal to 20. What I have now is quadratic. So let me bring everything over to the left like I would with a quadratic. I'm going to come up here. N squared minus n minus 20 equals 0. You have the power of 2. That means it's a quadratic. Bring everything to the left. And now you can factorize to solve this or use the minus b formula. I'm going to factorize it because it's a nice, easy one to factorize. It's just an n times an n for the n squared. I want factors of minus 20 to make a minus 1. And that would be 5 times 4 to make a minus. It would be minus and plus. They would multiply to make the minus 20, but add to make the minus 1. So I have that it's either n plus 4 equals 0 or n minus 5 equals 0. And that means n is equal to minus 4 or n is equal to n is equal to 5. Since then, of course, if I go back to my question, n is the natural numbers, we can disregard that one there. And the only possible answer in this context and in this question is n is equal to 5. Now, again, I know you probably could have hit on that if you did a little bit of trial and error on your calculator, but you could get something a little bit more challenging that you wouldn't be able to possibly just hit on. And this is the strategy. And it's nice to kind of understand the strategy, as I said, with this easier, just to understand how to expand out the factorials in order to be able to cancel. And it's good to understand it with the easier one to see how we can have a strategy that will work for us no matter what and solve for that unknown.